Hello, lovely humans, Jen Foxbot here. In this video, we are going to learn how to call the OpenAI Python API with dun da 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 an ESP32. So I am using, as you can see, the Adafruit MagTag because it has this really rad e-ink display. To show you how to call the OpenAI Python API, we are going to build a simple fun fact per day machine. And I wanted to share right off the bat what our fun fact is for today because it tickles me. So our AI display assistant, or Ada for short, says hippopotamuses secrete an oily red substance from their skin that acts as a natural sunscreen and insect repellent. Super cool. So you can build a project like this to bring you joy and inspiration, or you can take what I show you and adapt it for lots of other applications. So the quick version, basically, if you go to the GitHub repo and you grab the code, you only need to update a few things. So first, you want to go to the secrets template and put your SSID here, your Wi-Fi password, and then your OpenAI API key. So you will need an OpenAI account, which is free to set up, but I can't remember billing costs. It's not super expensive, but it may cost a little bit of money to use the OpenAI AI models. The other things that you can change, and if you're like, whoa, this is way too fast, don't worry, I'll slow down and we'll get more in depth. But for the folks that just want the quick version, the other things that you can change are the context, which basically tells the model some stuff about the role that you want it to play. The other things you can change are the prompt and the way that you display things. Okay, so now let's go more in depth and look at the whole program code in detail so that you can understand all of the pieces. All right, so this is our main file, and we will need all of these libraries loaded onto our device, which, if you're like, how do I do that? If you've never done it before, don't worry, we'll get to that at the very end. But if you go to the GitHub repo, which is linked in the video description, all of the libraries that we will need are included in that. So when you download the GitHub repo, it will give you all of those libraries, and then you just drag and drop onto the device. As I mentioned, you'll need to update the secrets file. The one thing I didn't cover was that the display name, I called it Ada. This is what shows up when you connect to your Wi-Fi router. And for those of you who are total beginners, your Wi-Fi SSID is just the name of your Wi-Fi. And then the password is how you connect. And finally, the OpenAI API key. So if you don't know how to get that, go to the Hackster tutorial, also in the video description, and I will walk you through that. I'm not going to cover it in this video because secrets are secrets for a reason. So yes. All right. So in our program file, first, we basically create a MagTag object so that we can add some things to it. And I'm using the super handy dandy Adafruit MagTag library, which works for this board. But the general application will work for pretty much any ESP32 that supports CircuitPython. So we are going to format the text display on the MagTag so that I can write little fun facts and quotes and things like that. And now we're defining some variables that we'll need later. So I'm going to define a variable to hold the model's response. I'm going to define the context. So in this case, I'm telling the AI model that I want it to be funny, accurate, hopeful, and enthusiastic, and an educator. So this is the role that the model is going to play. This is called setting this context and submitting a specific prompt or request to the model is called prompt engineering. And it's a little bit nuanced. There's a reason why they call it engineering, because it takes some practice to figure out how to actually get the AI model, or the large language model, or LLM for short, to do what you want it to do. And so what I would recommend as you're exploring and learning this stuff, start with mine and then change little things here and there, and you can see how it behaves differently. I also told my model that it loves sharing inspiring quotes, messages of self-care, and fascinating facts. So these are the types of things that I want my model to focus on. And every day we get a short and complete fact or quote from a range of subjects. And then I wanted facts from all different areas of knowledge, and so I included a very long list. And then finally, this is a little bit redundant with my prompt, which we'll see, which we'll see later. But I wanted a new fact every day. Okay, so that's the context for our model, how we want it to behave. The next thing that we need to do is to take the OpenAI API key and load it in. So that's where that comes in. The other thing that we'll need is the OpenAI API URL. We are using a completions AI model, but you can also use the chat model. You can also use the Dolly. There's some other types of AI models that you can load in. And so if you use a different model than what I do, or a different flavor of model, I suppose, there's different types of completion models that you can use. If you use a different flavor of model, you'll need to change this. Just quick caveat, OpenAI does actually recommend the completions model over the chat. At least the last time I checked the Python API, which was last week. Okay, so this chunk of code is how we connect to Wi-Fi. I'm not going to get into it in detail because lots of folks have videos covering this. But basically the gist is that we scan the network looking for the name of the Wi-Fi that we gave it in our secrets, and then we connect to it with the password. All right, so the thing that I really want to focus on is this function that we defined here, this get response. So this is getting the AI model response based on a prompt that we will give it in our while loop. Okay, so the first thing is to send a request to create an HTTPS request so that we can connect to the OpenAI model. And because we have a low power device, we don't want it to be connected to Wi-Fi all the time, only when we need it, which is when we go and ping the OpenAI model. We ping ChatGPT or whatever. Okay, so we will need our API key. We will also need some data, the model request parameters, basically. So that includes the specific type of model. In this case, I'm using Text DaVinci 002. You can change that, for example, to be GPT 3.5 Turbo, which is a bit of a newer model. That's kind of a fun thing to play around with, so you can see how the different models behave. We also will need a prompt, which we will input into the function. And so that gets sent to the OpenAI API. The max number of tokens is basically like the chunks of characters. So it's a little bit loosey-goosey, but a token is like about 4 to 6 characters, I believe. It does include white spaces and all sorts of other things. Every model has a limit to the total number of characters that you can request, total number of tokens that you can request. The max number of tokens includes our prompt and our context, all of the things we're sending to the model, all of that text, and all of the things that we're getting back. So I kept this somewhat short because I have a small screen and I didn't want to scroll. And so I don't need a lot of chunks of text. I don't need a lot of tokens. I do also believe that this is how you're billed based on the number of tokens that you send and receive. Don't quote me on that, but there's something about the amount of cost in that. Okay, so the more fun things, well, I guess prompt and model are fun, and tokens can be fun too. But the way that we can change the model's behavior in addition to prompt engineering is by adjusting the temperature. So the temperature refers to how much the model makes shit up, or folks have been calling it hallucinating. So for the OpenAI API, this is a range from 0 to 2. And at the higher the temperature is, the more the model makes things up. So if you want to use the model to help you write a creative sci-fi book or short story, you can increase the temperature to get some wild and wacky ideas. If you want the model to be more of the educator role, and in my case I don't want it to make a lot of things up, but I do want it to be a little bit creative in where it searches for facts. And so I reduce the temperature not totally to 0, but enough so that it would try to stay factual, quote unquote. And again, like, this is an AI model. It's not necessarily guaranteed that it's 100% accurate. So don't walk around as if you have all of the knowledge in your back pocket because you're calling the ChatGPT AI. You'll definitely want to check any facts that you're not totally sure about. Okay, so the frequency penalty and presence penalty, I tend to get these confused, especially when I'm on a video talking about them. But basically, these can range from -2 to 2, both of these can. And when you increase it, so positive values penalize repeated tokens. In other words, it reduces the likelihood that the model will repeat itself, both in new responses and in within a given context, within a given response. So this is how you can get new content from the model. Okay, and so now that we have the data that we need, we can actually submit an HTTP request to our OpenAI API. OpenAI API. It's hard to say sometimes. So it includes, we're calling the API URL, we're giving our data, and we are including our key so that the API knows we have access. And then the rest of this function just basically handles the response that we get back. It kind of formats it so that we can get the model text back. So basically, if you're typing to ChatGPT, the thing that it types back, that's what we want to grab. There's a bunch of other data called metadata associated with the response, which can be really helpful. And so if you're curious, you can play around with this or just print the entire response, which would just be this, basically. Okay. So now we set up our infinite loop so that our ESP32 will call the OpenAI API with our fun little prompt and our context once per day. It will get the model response and it will print it to the screen. So this is where we need to define our prompt, where I want a new fact every day. And so this is my prompt for today. And then we need to call we need to use the function with the context that we gave it above, the prompt that we just defined here, and this is really important, the response that we got back last time. So we defined that at the very top, but it's an empty string because for our first call, we haven't gotten a response. The reason why we need to include it in the full prompt that we're sending to the model is by including the previous response, it means that we won't get a repeated fact. And I played around with this a lot, and I did find that if I didn't include this, I would get the same fact over and over again. So I encourage you to test that out yourself. But if you want new facts or new information or different things every time, it's really important to include the previous response. Because, hey, the model can't remember, so we have to tell it the things that we've done, or that it's done. Okay, and then once we get the fun information back from our ChatGPT model, we print it onto the screen. So this is basically just, hey, our Ada bot says some stuff, our response. And then we refresh the screen. And finally, because I only want one fact per day, I put the board to sleep for 24 hours. Whoops, that one. And if you want to change how often you get facts or how often you call the OpenAI API, you change this time, basically. So we got 24 hours because it's 60 seconds in a minute, 60 minutes in a day, 60 minutes in an hour and 24 hours in a day. So you can increase or decrease by adding numbers to this or multiplying numbers. Cool. And then we just get some error handling. So that's pretty much it. So very quickly, I'm going to show you how to load the data onto the device. So we are going to open our file code, and then we are going to open the device, which shows up like a USB device. I'm not going to update the secrets file because with the template, it wouldn't connect to the internet, and secrets are secrets for a reason. But I can, what I do is I just drag main.py, oops, yep. We do want to replace, and you can also just drag this whole folder for our libraries onto the device. I'm not going to do that right now because it'll take a hot second. And then once we do that, that's pretty much it. My USB device is very short, and so that's really cute. Here is our new fact. If you can't read it, it says, Ada says, today's fact, laughter is the best medicine. I guess that's a fact, but it tickles me, so I'll accept it. All right, so that's pretty much it. That is how you call the OpenAI Python API with a little ESP32. All right, please let me know if you have any questions, if you have any other kind of demo requests for putting or calling the OpenAI models with little microcontrollers, and we'll see what we can do. Thank you very much for watching, and we'll see you next time. Bye!